So in that case, as we saw, the answer was A for sensitivity. All right, now we have a really kind of a crossover point question. So we have a landscape company, and you have two options. You can either lease your additional equipment or you can purchase it. So what we want to do is we want to find out the in this case, we want to find the equation for profit for the lease option. I'm sorry, this is not a crossover point, it's just a simple profit equation. So what we're going to do here, if you remember, the profit equation is a pretty straightforward one. We're going to have our selling price times our quantity minus our fixed price, minus our variable cost times our quantity minus our fixed cost. So that's going to be 85 times our quantity. This is going to be the amount of revenue that we bring in. And 25, which is our variable cost, times that same quantity, is going to give us our expenses, our variable costs, and then we're going to take away our fixed cost. So, and if we take away the 25x from the 85x, we get 60x minus 6,000, which is our fixed cost. So we come up here, it's answer number C, or choice number C on our multiple choices. All right, and we have here, well, why are we using random numbers, and what are the sources of the random numbers? So we can use random number tables. I talked about the backs of books. We can just pull out numbers out of a hat, or we can just roll dice. So really, it's really all of the above are certainly good choices for generating random numbers. All right, and a map is what type of a model? We covered this a number of different times, also covered in the book. I think even the book actually has map listed as one of the analog types. So that one should have been a slam dunk for most folks. And then number 20, model validity, means that it accurately reflects real world and providing meaningful results. All right, so we had a number of other choices. So model validity was again one of the concepts that we talked about in the class, and it was also a concept that was reviewed in the text too. So for those of you who went through the notes and came to class and read the text, should have picked up on that one as well. Separation of player's curse, we also covered in class, and this is when the person building the model is different from the people using it. And this can happen in a lot of cases. Sometimes it'll be the management team. Problems there, problems with people that the model builder has to give the model to let them try to use it. But it just causes lots of problems in model building. And good model building helps to reduce the separation of player's curse if you do a good job in building it and make it easy to use and clear and accurate and make a good business case for it. All right, number 22 is it's best to simply compare averages when selecting between alternative decisions. No, we don't want to just do that. We want to use some of the more advanced techniques that we've talked about in class, whether that's using crossover points, whether we want to use simulation. We can run simulations to compare different options. We don't want to just take simple averages. And the next one, number 22, so that was false, B. And number 23, in a queuing simulation, the number served is the greater of the total in the system and the total capacity. Does that make sense? No, you can't really do that. The number of served is going to be the lesser of those, because your capacity is how many people you can serve. So the most you can serve in any given simulation or any given period in a simulation is the total capacity. It's going to be the less of the two. And then what's left over to add to the queue next time is the difference between those. All right, in the profit equation we have we can either make something or buy it, and we have two profit equations, 4x minus 23, 7x minus 35. The crossover point is going to be where the profit's the same. So we've got two ways. We can either solve this in the classic way, where we subtract the contribution margins and subtract the fixed cost, or we can just set these two equations equal as it's done here. So we set them equal, 4x minus 23 equals 7x minus 35, and then we just simply solve for x in this case, and x equals 4. The other option would have been to simply do 7 minus 4, 35 over 35, minus 35 minus 23, and we would have gotten the same answer in that case if you used the formula that we had used for crossover point. And in this case, probability range is 253. How many random numbers do we need? We're going to need to have 1,000 random numbers. If we're going to pick a number between 0 and 999, we're going to have 1,000 random numbers. And we have, because we have 3 digits here, we would roll, we would roll 3 dice to give us from 0 up to 999. So in this case, we're going to have 1,000 random digits. In Excel, we have now this one, you're just going to have to think about this. This is that absolute reference problem. And if we have these values in the cells and we drag, or we copy and paste or drag the value in D6 to the value in D5 down to the value of D6, when you drag down, what's going to happen is it's going to drag the B value down, but it's going to drag the B3 value down, but it's going to keep that value the same. So if our formula, in this case, it's going to keep that reference the same, but it's going to be B4 plus C3. In this case, it'll be 15 plus 50. Fixed cost is doubled and contribution margin is doubled. The break-even point would be what? Well, of course, because these are a ratio, the ratio is not going to change if you double both of the values. So the answer here would be unaffected. All right, in this case, some of the key steps in the development of the modeling process are these, and then the proper order are, if you see down here, it's answer C. So the first item is diagnose the problem, then we're going to select the relevant aspects, then we're going to organize the facts, construct the model, solve the model, and then we're going to do the sensitivity analysis. So most of you guys got that one right as well. And probability distribution is uniformly distributed, and that's not the case here. If it were uniformly distributed, all these probabilities would be the same. Is it possible to build a model with the goal of maximizing sales? Of course it is. We can maximize sales, we can maximize profits, we can really set anything to be the goal of our model. What is the profit? So this is again a pretty simple profit model. When we have a quantity produced and sold as 100, fixed cost 2,000, contribution margin 40, our simple profit, contribution margin times quantity minus fixed cost, do the math, we come up with 2,000. Now we have our checkers queuing model, and this one's pretty straightforward as well. We have 3 periods, and in this case what we had down here, we had our missing values down here on this final row, and our ending queues, as we used our random numbers, so our 22, 26, and 11 ended up here. 11, 18, or 88 and 67 are here, and server number 2, random numbers, are here. And using the tables we have up here for the arrivals and the servers, we come up with our arrivals, our number that they could serve here and here, and we come up with our ending queue by just figuring how many people were already there, how many people came in the door, how many each server served, the total number served, and the ending queue. So our ending queue is 2, 4, and 2. We add that up to 8. We divide 8 by 3, and we come out with 2.67 as our answer. And last but not least, find the values for row number 2 in the table. And in this case, it's pretty straightforward. We had an ending inventory of 7, so we just carry that down. So we have a beginning inventory of 7. We ordered 10, we ended up with 17. Demanded was 13, we sold 13. Ending inventory was 4. And unit lost sales 0, because we had enough in inventory to sell. So our solution is E. Okay, well, hopefully that gives everybody what they need to help study for the final, and I look forward to seeing everybody in class. Thanks a lot.